Okay, for this video I'd like to do some questions on the equations of constant acceleration. I'd like to see somewhere we just see how the formulas work and how to use them exactly. Okay, we can start. So first question, assuming constant acceleration, find u when s equals 60. Okay, find initial velocity, which is u, when displacement is 60, velocity is 13, acceleration is 1 if the object has not changed direction during the motion. So this is how I was taught to do it, and I feel like it's one of the best ways to do it. We write down these equations using the acronym SUVAT, where S stands for displacement, U is initial, V is final, A acceleration, T time. And then we label what we are sure we have. So we have the displacement, which is 60. We have the final velocity, 13. We don't know the initial velocity, that's not given in the question, that's actually what we're trying to find. And we have the acceleration as 1, and we're not given any time at all. Then check to make sure that all the units are correct. Displacement is in meters, velocity in meters per second, acceleration in meters per second squared. Then we can now look for the formula that we need to use. So how do you look for the formula that you need to use? Look at what we have. We have S, V, A. So the formula we use must have S, V, and A. And we're looking for U, so the formula should also include a U, because that's what we're looking for in this question. So we're going to look for a formula that has S and U and V and A, or in other words, the formula that does not have the T. And if we look at this has a T, well, that doesn't have a T. So we're going to use V squared equals U squared plus 2AS. So V squared equals U squared plus 2AS. What's V squared? 13 squared equals to U squared, which we don't know, plus 2 times acceleration, which is 1, times S, which is 60. Okay, then we'll have 169 is equal to U squared plus 2 times 1 times 60, that's 120. Now we can move the 100 to the other side, 120 to the other side, so we'll have 169 minus 120, which is actually 49, I should think. 49. That's it. So U squared is equal to 49. We're going to square root this, square root that. So when we find the square root of U squared, we'll have U is equal to plus or minus 7. Well, they told us that the initial velocity, well, that's what we found, plus or minus 7. And they tell us that the final is 13, and that's a positive 13. That means it's moving in a certain direction with a speed of 13. Well, if we took the minus 7, that would probably mean that it was initially moving in the opposite direction. And yet they told us that the object has not changed direction. So instead of taking the negative answer, we're going to ignore that and we'll just say U equals positive 7, because it should be moving in the same direction. Positive 7 will be in the same direction as positive 13. While the negative answer, because you know square roots have a positive and a negative answer, that would be in a different direction. Let's try out another question. A car is traveling at a velocity of 20 when the driver sees the traffic lights ahead change to red. He decelerates at a constant rate of 4 meters per second and comes to a stop at the lights. Find how far away the lights are. Find how far away the lights are when the driver started braking. Okay, let's calculate that. So we'll start by doing with the SUVAT. S-U-V-A-T. SUVAT. Okay, then what next? We're going to label what we're sure we already have. So we have the S. The S is, do we have the S? Nope, not really. The car is traveling at a velocity of 20 when the driver sees the traffic lights. So that's the speed at which the car starts out actually. It's not the final speed, that's the speed that the driver has before she starts braking. So that's going to be the initial, or U. So U is the initial velocity, which is 20. And then he decelerates at a constant rate of 4 meters per second. Now we need to be careful about this. Decelerating. How can we show decelerating to differentiate it from accelerating? Accelerating, increasing in speed. Decelerating, reduction in speed. So instead of saying our acceleration is 4, because it's decelerating, we're actually going to say it's -4 to say that every second the speed reduces by 4. So maybe 20, then 16, then 12, then 8. So every second the speed keeps going down in jumps of 4. What else do we have? Now this is important. He comes to stop at the traffic lights. What does that tell us? Whoever is he coming to stop or coming to rest, that just means that the velocity there is 0 meters per second. So at the end, after the braking, his final velocity is 0. That's what we need. They're asking us, find how far away from the lights the driver started braking. So we're going to look for an equation now. So how do we do it? We need to first of all see what we have. We have u, v, a. So our equation must include u and a v and a a. And then we are looking for how far. How far? That's going to be displacement. So our equations have s, u, v, and a. Because we have these three, well, we're looking for the s. So again, going to look for an equation that doesn't have a t, and we've already seen it's that one there. So v squared is equal to u squared plus 2as. Let's substitute what we know. V squared is 0, u squared is 20 squared plus 2. The acceleration is -4, and we've got s. Okay, so what can we do here? We can say 0 is equal to 20 squared is 400. 2 times -4, that's -8s. 400 equals -8s. Now we can move the -8s to the other side. That becomes 8s equals 400. So then s will be equal to 400 divided by 8. That's going to be, I think, 50. Yes, 50. And we need to include units here, so we're going to say 50 meters, something like that. Yeah. Then we can try out the next question. Let's see the next question. An airplane accelerates at a constant rate along the runway from rest until taking off at a velocity of 60. We need to calculate. The runway is 400 meters long. Find the acceleration of the airplane. So let's see what we have. We'll put down our SUVAT. SUVAT. S-U-V-A-T. Then we're going to look at what we have. What do we have here? We've got the aeroplane accelerates at a constant rate. So remember again, this equation only works when the acceleration is constant. From rest, the airplane accelerates from rest. What does that tell us? That the initial velocity is 0. That's where they start out. Until it takes off at a velocity of 60. So when it sets off, it's moving at a velocity of 60. The runway is 400 meters long. Okay, the runway is 400 meters long. That's just displacement. Find the acceleration of the aeroplane. So we're looking for the A right there. So it seems we're using the exact same equation we've used the whole time. V squared equals u squared plus 2as. We're going to use the other equations maybe later. So we'll have v squared is equal to u squared plus 2as. Because we have s, we've got s, we've got u, we've got v, and we're looking for the acceleration. So v squared is 60 squared is equal to u squared is 0 plus 2. The acceleration we don't know. The displacement is 400. 60 squared, what's that gonna be? 3600 is equal to 0. That's just going to be removed. 2 times 400 is 800a. 800a is equal to 3600. Let's see how I would do that. 800a is equal to 3600. 800a equals 3600. Let's divide through. Let's remove the zeros first. Have 8a equals 36, such that a is equal to, is it 4.5? I think that's the answer. 4.5. Because 8 times 4.5 is 36. Yeah. And we must put units. The units for acceleration, that's meters per second squared. Or sometimes written like that. Let's look at the next question, the final question. The second last question actually. A motorcyclist sees that traffic lights are red 40 meters ahead of her. She is traveling at a velocity of 20 meters per second and she comes to rest at the lights. Find the deceleration that she experiences, assuming that it is constant. So let's again write that. SUVAT. Let's use a different color this time. Maybe rainbow. Just make it a bit thicker. SUVAT. What else do we have here? Let's see. Sees that the traffic lights are 40 meters red ahead of her. So 40 meters, that's talking about distances and displacements. So 40 meters. She is traveling at a velocity of 20. So velocity of 20 and comes to rest at the lights. So which of those is the initial? The one that was there first. So 20 is going to be our U. She comes to rest at the traffic lights. So coming to rest, that's 0. That's the final velocity. Find the deceleration. Now it's talking about acceleration. That's what we're going to calculate there. So let's look at this. We're going to make the equation. This is the same equation for all these, but we're going to see some questions where we use different equations in the future. Let's look at that. So let's look at the equations again. Calculate that. I'm going to use the same equation. V squared is equal to U squared plus 2AS. V squared, V is 0, so 0 squared is equal to U squared is 20 squared, or 400 plus 2 times A, which we don't know, times 40. If we continue, we have 0 is equal to 400 plus 80A. We can move the 80 to the other side, so that we'll have 80 negative 80A is equal to 400. And when you divide through by negative 80, we'll have A is equal to negative 5. So the acceleration, the deceleration here is negative 5 meters per second to the power negative 2. And this makes sense because the car starts at 20 and then ends at 0. That means its speed must be reducing. So yeah, that's it. Assuming constant acceleration, find the time for positive t at which the following situations occur. So for this question, they're asking for time, and there we're going to have to use a different formula. Let's just try it out, but we'll tackle that in a different video. Let's see. So assuming constant acceleration, find the first time for positive t. So let's write this down. Let's write SUVAT. We've got the initial displacement. We've got displacement 24, acceleration negative 2, U 10, and they want us to find the time. So let's just try out finding the equation that we need to use here. So we've got S, we've got U, we've got A, and they've asked us for time t. So we need to look for an equation that has S, U, A, and T, which is what we're looking for. So that equation is not going to include the V. Which equation is that? This has a V, this has a V. It's going to be this equation there. So we substitute. S equals UT plus a half AT squared. S is 24 equals 10t plus a half negative 2t squared. So 24 equals 10t minus 1t squared, and that's the equation. And we'll look at how to solve this in the next video. But for this video, we've mostly been working with a single equation, but we've just there at the end, I just wanted to show how you could probably start on working with another of these equations. We'll work on these two equations in a single video because they might involve having to solve quadratics, and these two are quite easy. And we'll do some questions on them as well. But I think that will be it for this.